This video is about the methodology of web application attacks and a systematic approach to detecting and exploiting vulnerabilities. Hacking is not a single action, but a methodology. We will explore key attack vectors targeting each component of a modern application, including the client, web server, application logic, APIs, web services, and database. Module 1 is about authentication attacks. This includes brute forcing usernames and passwords, exploiting password reset flaws, and bypassing multi-factor authentication by manipulating server responses. Module 2 covers session management attacks, which aim to intercept the conversation. Key techniques include predicting or brute forcing session IDs, exploiting session cookies via cookie replay, and session fixation. Module 3 focuses on authorization attacks or privilege escalation. This means gaining access to functionality or data that you are not authorized for, even after successful authentication. Attack vectors include parameter tampering and exploiting insecure direct object references, or IDOR. Module 4 addresses injection attacks, forcing the application to speak your language. The principle is sending specially crafted data that the back-end interpreter, such as a database or OS, mistakenly executes as a command. Examples include SQL and OS command injection. Let's take a deep dive into the anatomy of an SQL injection. A vulnerable code allows malicious input like admin01 equals 1 to be passed. This makes the logical condition always true, resulting in unauthorized access to all user data. Module 5 covers application logic attacks, which involve breaking the rules of the game. These vulnerabilities are flaws in the business process or workflow, often based on false assumptions by developers about user behavior, allowing attackers to skip steps like payment. The modern frontier is the attack on web APIs and web services. APIs are new front doors that provide direct access to the application's logic and data. Key attack methodologies include parameter tampering, injection attacks, and authentication/authorization flaws. The main risks for APIs are highlighted in the OWASP Top 10. These include broken object-level authorization, broken authentication, broken object property-level authorization, and broken function-level authorization. Attacks on the client target the user. Cross-site scripting, or XSS, injects malicious scripts to steal user data or perform actions on their behalf. Cross-site request forgery, or CSRF, tricks a logged-in user into sending an unauthorized command. Clickjacking overlays an invisible frame to deceive the user. The defense methodology involves proactive security testing. This includes static application security testing, SAST, which analyzes source code, and dynamic application security testing, DAST, which tests the running application from the outside, often using fuzzing. Key countermeasures for defense include validating all input data, applying strict access control, implementing security by design, using secure frameworks, and logging and monitoring all security events. In conclusion, effective hacking is a systematic process. It involves deconstructing the application and verifying every assumption made by the developers. To build a secure application, you must first learn to think like those who will try to break it.